Terry Akel, systems engineer from Juniper. Tracy and I are both local, and we've got a table here at the show, so feel free to stop by and we can give you more detail if you so desire. So again, we're going to talk about software-defined secure networks and sort of what our vision and what Juniper is doing. So first off, if you're a CISO or you work for a CISO, obviously they feel a lot like they're treading water, because it was recently in the last couple of days, the big DOS attacks that took place. Most of you probably heard about that. Ultimately, those are the things that are keeping these folks up at night and keeping us up at night in a sense, because if I take my hat off, I'm a user just like you are, right, in regards to data, and all my data is also at risk just like corporate data is, right? So ultimately, those kind of things are what keep CISOs and folks treading water. And there's billions of dollars going into networks to secure them, to protect, to put sort of shields or whatever you want to call it around it to try to make it more secure. But ultimately, how do you measure success today? Mostly by the number of attacks that are blocked, but that doesn't necessarily mean that you're at less risk. Those are the kind of interesting things that we'll talk about today. And attackers are always innovating to increase their ROI. Anybody here been hit by a ransomware yet? Yep, ultimately corporates have individuals now or whatever, and ultimately I know I've got a couple of relatives or whatever, I get the phone call because I'm the network guy, right? And ultimately, hey, I've got the blah, blah, blah calling me and saying that they'll give me back my computer if I give them $200. I'm thinking, nope, just go back to your restore point, click that, boom, and away you go, right? So there's kind of interesting things that are happening. So threats are everywhere. Obviously, you know that. It is a zero trust world. Whether you're inside the net, outside the net, whatever, you have to really treat it as zero trust, because if you were on the outside of your network yesterday and you come on the inside of the network today, that means ultimately now you just brought in what you had with you on the outside. Just the way that works. So we're going to see how we deal with that. And obviously we're seeing attacks are more diverse and variable. You guys see that as well. Data security across network is crucial, and we're going to see how we apply that. So this is the traditional security thinking that we're used to. Layered on top, not really integrated in the network. I call it the hard crunchy outside, soft gooey inside, right? That's really the kind of the mentality that most folks have had in the security process. Relies mostly on traditional firewalls for data and insight, but you need to go beyond a traditional firewall in protecting your network, because a firewall protects you from what? Outside coming in, most often, right? And ultimately, what happens if you're already on the inside? If you are in a model of everything is trusted on the inside, it's a false sense of security. And then we're going to talk about that. Today's network security must be dynamic, automated, and intelligent, effectively detecting and stopping evolving threats. Meaning you have to think about how can I detect, where can I detect in my network? Because ultimately stuff coming into you from the outside is one point. But what about all of folks and devices that are already on the inside? You needed to be able to detect that as well, because they could have infections that they got from somewhere else. So let's think about that. To stop threats faster, you have to start thinking about secure networks, not network security. It's a total different mindset. Total different mindset. Realize that threats are already on the inside. You may not think they are, but they already are on the inside. And ultimately, the only way that you can mitigate it is to detect them on the inside. That's the only way that works. So if we think about that, and you kind of set the premise that perimeter security is not enough. You need more than that. And you also need to be able to enable detection and enforcement anywhere and everywhere in your network. Every port of your network should be intelligent enough to be able to detect an anomaly, a change in behavior, and mitigate it. If it can't, then ultimately that process that's taking place will spread in your inside of your network. That's the problem. Okay? So let's take a look at what the thought process. Normal behavior, call home, you get beacons, energy utilization, that's normal because that's typical healthy, but then all of a sudden, abnormal or anomalous behavior, you've got bursting traffic, abnormal high download data rate that wasn't there before. Well, how do you know that? Well, ultimately, you have to be monitoring your network to know and understand what is different and happening that's I'll call it a not normal behavior. For example, you have an inside machine that's now all of a sudden loading megabytes of data outside your organization. Well, that's not what that application's supposed to do. That app is talking to this database. Why is it sending data outside my network now? That's abnormal behavior, okay? So things like that you have to be aware of. So is this normal? How do you mitigate risk? So let's think about this. In the Juniper process of software-defined secure networks, you want to create and centrally orchestrate an intent-based policy. SAM can talk to this server, but not this server. Or the financial folks can talk to this application, but IT folks can't. That's intent-based policy versus, well, this IP address can talk to this subnet, or this IP address can talk to this IP address. That's not really a business policy mentality. That's more of a network look at what the network should be versus a business policy intent. Who should get to talk to what app, or what app should talk to what database? That's really what you need to look at. So from the perspective of policy, you really align your security to your business imperatives, not what VLAN talks to what VLAN, because that's not really, that's more of a mechanics network piece of it. You really need to take it up a layer and understand that process. But there's just as important to be able to have a detection process, gather and distribute that intelligence from multiple sources. You need to be able to gather information from outside, third-party feeds, GeoIP feeds, blocking, all of the intelligence you're gathering, and get it integrated into your network, not just look at a small footprint from that perspective. And then leverage cloud economics for real-time analysis. We'll talk about that in kind of our architecture in a little bit. And then enforce the mitigation point, or enforce the stoppage of that threat from mitigating. Automatically apply the policy in real time. Zero-day threats, right? Most people are probably familiar with that term anyway. From a zero-day threat perspective, it means that there's no signature yet, right? Because it hasn't been created, right, to stop something. So how do you stop the mitigation? Well, if you see an abnormal behavior, mitigate and isolate it before a signature has to be written for it, right? Does that make sense? That's ultimately what you need to be thinking about. So what's the software-defined secure network all about, and what is our kind of our strategy from Juniper? Really, the idea is to leverage knowledge and integrate it into your network. Not your firewall only, but your network. That's really what's important. So if you think about it, the security cloud from Juniper really has multiple points of information that we have gathered and have sort of fed that knowledge. I always say one head is good from information, but 5 heads are better. Thousands are even better, right? If you have thousands of points of information from the perspective of your customers that have been attacked and or threat vectors have been attacked, and you have that knowledge, you are actively taking that knowledge, information, and being able to apply it to your network infrastructure. That's really the thought here. So if you take a look at it from the perspective of you're detecting in the cloud, you've got third-party threat information, separate feeds, like from RSA, third-party intelligence that you're feeding into the process. And then you are creating sandbox environments to be able to say, oh gee, Sam downloaded this executable, is that a threat or not? Well, do you take that executable and you launch it in a sandbox and explode it so it runs, and then analyze it? Is it bad? Is it doing something? Is it calling out to a bot? Those kind of things you do, and if you find out that indeed it does have an embedded malware or process that calls out of your environment and shouldn't, then ultimately the feedback comes back and isolates Sam, because Sam, you downloaded that. We're not going to hold this file hostage. That wouldn't work, right? Because suppose we were all in a room and we were all downloading files, and I downloaded a file and I wasn't going to give you that file till I ran analysis on it. Guess what we're going to do? We're going to pick up the phone and we're going to say, hey, the networks, there's something wrong with the network here. You know, I tried to download X, I tried to download Y, and I didn't get it, right? We're not going to hold that file hostage, but we are going to analyze that file, break it apart, and then come back and say, yeah, that was a bad file, Sam. You're off the network now, but probably Sam already called IT and says, yeah, I can't get on the network. That's because you got a problem, right? That's what happens, right? You ultimately have to find out if it's bad, isolate Sam so he doesn't spread it any further, and then he calls for help. But you mitigated it, right? You blocked it on the network. That's the key. So that's the cloud piece. Then you have this green portion here, which I call it the enforcer. Anybody watch Netflix and see the shows or the enforcer movies or whatever that are out there? Ultimately, the idea is you can detect things, but then you need to create a policy and enforce that policy. That policy needs to basically be sort of live, automated, and created based on the fact of what you learned, right? If you learned something bad, inject into the policy something where you can mitigate and block that issue that took place. So have that policy be created at that engine, and then apply it to your network, not just the firewall, but your network. Router ports, switch ports, your fabric in your data center, whatever the case might be. The key is that every point in your network becomes a detection point and an enforcement point to protect your network. That makes sense? Because if you're already on the inside of your network and you don't have an enforcement point, you got a problem. Because now you're going to continue to spread that issue, malware problem throughout your network without having an enforcement point. Kind of make sense? So that's the architecture, and that's kind of the thought process. And then this process down here in this lower right-hand corner, and all of these blue boxes are wonderful Juniper gear, but we also have the opportunity to apply it to third-party elements, someone else's device, as long as they have a well-defined API that we can apply that mitigation point through a well-known API. REST is a very well-known good API. Or the netconf protocol, which is a secure shell-based protocol that allows me to push a change to a switch through a netconf protocol. The idea is that I don't really care whose device this is as long as they have a well-defined interface and you can push it down to there as well. That's the idea. Okay? Make sense? So if you think about it from the perspective of the three pieces, really you have a unified and responsive network environment that has detection points throughout your entire network as well as enforcement points throughout your network. And you leverage the entire network and ecosystem for information. Not just one piece, meaning just at your firewall, but through all of the points throughout your network. You take the malware knowledge that you've gained in the cloud. You take the dynamic adaptive policy piece of it. You change it as you learn things, because ultimately if you discover something, you want a policy that can write a block, if you will, based on what you just learned. That's dynamic. That's not Sam going, gee, now I'm going to apply this policy that I just had to figure out and write. You want the policy to be created based on what you learned. Kind of make sense? That's really dynamic. And then ultimately, you apply it to any element of your network, whether it's your campus, your data center, whatever the case might be. So, the right policy for the right job. If you turn off the entire network, shut the light bulb off, that's a bad thing, right? Because all of a sudden, everybody now is basically inactive, not productive. What you really want to do is kill a bad tunnel that's going outside of your network that's delivering data where it shouldn't go. You want the policy to tear down the tunnel that's going somewhere else. That make sense? So more sensible, I'll call it laser-focused mitigation, okay? So in summary,
software-defined secure networks delivers on the promise of a truly...
Oh, there's a voiceover on that slide. Interesting. I had my speaker like this. So I'm going to not listen to the voiceover here, only because I'll speak to this slide. But ultimately, let me go back into this. Okay.
Software-defined secure networks delivers on the promise.
Let me see if I can, I'll just leave it in this mode, because ultimately I don't want that voiceover to go. So really, in summary, what I've been talking about is I've been talking about every point in your network becoming a detection and enforcement point. And really, if you take a look at it, you're not doing your traditional mindset in network security. What you're really doing is you're taking business continuity and reducing your risk profile, and it's becoming adaptive, and there's immediate protection, that 0-day process, right? You're reducing your OpEx costs because you're unifying your management and visibility, which I'm going to show you a demonstration here in just a little bit. And then you want to basically have a deployment flexibility where you have on-premise or virtual cloud or a blended. So you can do on-premise based stuff where it's in your control, but you could also have cloud integrated with it, where you have that cloud knowledge coming into your environment, and I'll call it making your network more intelligent because of a knowledge gained across the industry and world and coming to your network, if that makes sense. The idea is if you're one organization, but you have 50 other organizations like you and they're getting attack vectors, you want to take that knowledge that they have been getting from an attack vector and apply it so that you can already have it protecting your network without having to go experience it firsthand. That's kind of how I look at it. The ultimate idea is gain knowledge. If someone has already, quote, blocked a problem, you want to apply that to you as well, if that makes sense. And then investment protection. Simplified UI for orchestration, automation, and reporting. And I'm going to show you some of that from the perspective of one of the components. And the component I'm going to show you today is literally the component we call Security Director, and it's part of our overall solution here. And I think it makes sense to kind of at a high level introduce you what that looks like. So you, as we'll call it, the keepers of the network or the security process, you can kind of see what visibility you get, where that information is gathered from, and then ultimately how easy it is for you to gain knowledge and where those threats are coming from. That's kind of the idea from that perspective. So with that, I'm going to switch windows here, and we'll go into my dashboard. So hopefully you can see that okay. So just to kind of give you a premise of what you're seeing here. This is the Security Director. It's a visual GUI or web GUI that is part of the policy engine that I showed you on the one slide, which is part of that policy control. That Security Director is what I'll refer to as the visibility into the secure network. Okay, that's what you're seeing here. So the first thing I did is I logged into this. This is running in the cloud up in AWS, and I logged in and I come into a dashboard. So ultimately, the first thing, if it was your instance, I'll call it, whether it was on-prem or in the cloud, depending on where you decide to do it, you would be able to customize your web GUI. So your operation folks, your network folks, or your cybersecurity folks, or whatever, could customize it. And you ultimately can go down here and you can simply say, I want to select one of my widgets up here, so I could literally customize it. And because it's a roles-based process, you could have a NOC that's a read-only access, and they could have a dashboard that looks like something. Then you could have maybe the cybersecurity guy who's read-only and write, meaning you want him to be able to write policy or be able to adjust policy, whatever the case might be. And so you would give him read-write access, if that makes sense. Two different logins, two different views of the network, if that makes sense. And you can simply drag and drop any of these widgets anywhere on the dashboard here and be able to adjust it. So very, very simple from that perspective. Then if you kind of take a look down here, of course, this is written in HTML5, so it's all active-based widgets from the desktop perspective. So then you could simply come down to here, and if we come down to here, you can see one of the widgets is a threat map virus. We've also got other widgets down here. We've got threat map, IPS, and you ultimately can see when I hover over it, and from a visualization perspective, from the dark color, you can see this indicates that I've got this many threat counts that have taken place based on color of the icon, if that makes sense. And so ultimately, I can simply drill down. If I click into the US and I want to be able to get that data, now I laser focused. I had the sort of big picture. Now I just laser focused into just the IPS events. I want to go investigate that. So what I've just taken it from a sort of a global view down to simply an IPS event. And what it did, by the way, when I clicked on that, it immediately, because of where I clicked in location, it filtered down from that information directly on that piece. It already put the filter policy in there for me, if you think about it, because we have this database that was gathered. I drilled in on US, and that's all I'm looking at right now. So that's how that works. And then if I want to, and all of the monitoring works the same way. If I want to, I can now then try to focus in. Let's say I got a call or somebody said, hey, gee, from 2 to 3, we saw an extreme spike in data outgoing or incoming, and I want to focus on that window. All I simply do then is I simply squeeze the window down to what I want based on the custom size window, and this is either by hours, days, whatever, 30-minute increments or whatever, and I can just simply slide the window wherever I want. And I'm going to laser focus in on the data for only that piece, because that's all I want to look at. Okay, so that's kind of a mechanical piece that we built in that I think is very, very useful to look at it from that perspective. Additionally, if you think about it, I'm looking at just IDS IPS events. If I click on all events, you'll notice here, all events, I'm showing all of my my total events. I'm seeing firewall, web filtering, IDS IPS events. If I'm monitoring content filtering, anti-spam, all of those next-gen firewall portions of the network all act the same way in the way I can look at it and view it. So that the good thing is you don't have to learn something different for different pieces of the puzzle. They all sort of viewed the same way. So I like that consistency in the process. But additionally, you might rather have a view and look at the live threat map. And you might have maybe your NOC has this up, and you have the live threat map, and you have monitoring going on for IPS events, maybe for spam, virus events, or whatever, and ultimately you're looking to see where attacks are coming from, where they're going to, and you can kind of get a sense and feel for the fact of where hotspots are in your network. And again, the beauty of a live threat map is you can see if you're getting attacked from the outside coming in based on the policies and so forth that you've got written. And ultimately then again, I can simply drill down and go, and I can immediately go again to that threat, whether it's an IDS event, IDS IPS event, or an anti-spam or antivirus type of threat event. So very, very quickly I can go look at that. But additionally, sometimes I might want to say, gee, I want to go look at this not from the view of maybe an IDS IPS event, but I want to look at it from an application perspective. What applications are running on my network? And so you can simply, from the tool, click on application, and now the tool is going to give you the visualization of what apps are on my network. And so from the perspective, if you're familiar with heat maps or bubble graphs or zoomable bubble graphs, you can simply take a look here and get a very, very quick on what is the greatest user of bandwidth on my network. In this case, you can see in the upper right-hand corner, bandwidth is selected. I'm using a bubble graph, and right now, someone is misbehaving by using BitTorrent. That's bad, right? So ultimately, that shouldn't be going on in my network. They're consuming bandwidth, right? So at this point in time now, you can say, well, okay, I'm going to go investigate that. And so I'm going to hover over BitTorrent here, and I'm going to see, yeah, we got a few folks using BitTorrent, so I could simply from this screen say, block the app. Now, I don't recommend doing that because BitTorrent is a port hopping application. If you block that, it'll simply spin up another port and go onto another port and start all over again. So that would not be a good thing. What you might want to do instead is you might want to use the tool to say, I'm going to do a quality of service or a throttling of BitTorrent and squeeze it so it keeps the connection open but is unusable. Because then it won't port hop on you. And ultimately, you would rather choose to do that than totally killing it or blocking it. You may choose to block it by user. So let's say here I want Chandon to get blocked. I select that and I click block user. I do want it blocked for that user, but I'm not killing the entire app, but just that user is not using it. And I simply say blocked user, automatically will create the policy for you, And in this case, all I have to do is simply say, go update the policy, publish it, and it's done on my network. Very simple. The idea is make the visualization apply to your network very, very quickly. Okay? I'm going to cancel. I'm going to show you one more thing here, and I want to show you probably my favorite part of the tool because I got a couple of minutes left here, and that's what I like to call the how do I know if all my policies or rules in my policies are really being used? Are they in the right place? Am I blocking any? Are any being shadowed? If you're a security person or a cybersecurity person and you've got the person who's written a bunch of rules in regard to the fact of protecting your network, and then that person moved on to a different job. Maybe they're director now or they're outside the company, and someone comes back later and goes, gee, there's 57 rules here, or 100, or 1,000. I'm not sure what they were for, right? And I have a rule I need to add, right? How many folks have had that happen, right? Where I need to add a rule, I'm not sure where it needs to go, what these were for, but I really want to check to see is there any rules that are shadowed or not being used. So in this case, notice here, I've got a policy here called backup policy. It's got 126 rules in it. Well, I didn't write them, someone did, and I don't know necessarily what their intent was, but I want to be able to see, first off, are there any rules that are being shadowed or not used? Well, simply right-click, generate policy analysis report. I'm going to pull in that policy. It's going to look at that policy, and it's going to make a determination here. And I'm going to open it up, nice format called PDF. Most folks are familiar with it. And it just ran an analysis of that policy to determine if any rules of that policy are shadowed, not used, whatever the case might be. So if I scroll up here and go, oh, yep, I got one shadowed, I got 4 redundant, and I got 112 rules that are not being used. Geez, out of 126, that's not so good. Well, of course, we did that purposely, right, to kind of give you a sense and feel for that. The whole idea here is to be able to make efficient use and rules that are actually being used. And you actually see here, it says a rule is shadowed when a previous rule matches all the packets of that current rule, and the actions for each rule are different. As a result, the shadowed rule will never get hit. Kind of makes sense, right? That's why they call it a shadowed rule. And ultimately, you can kind of see here, here's the problem. Rule 121 is shadowed by Rule 120, self-traffic policy, and so it gives you some guidelines of what to do to correct it. That's great, because you didn't write that one, someone else did. But let's say you had to write a rule now, and you need to know where to put it. Well, as you create the rule, if you're going to create a rule and put it in an existing policy, it will give you a suggestion to where to put that rule to not shadow another rule or other rules. Very useful, right? Because again, unless you are a guru or a sort of call it a rocket scientist that knows how to be able to understand where to put that, you want to get some good suggestions of where to put it so you don't shadow stuff or negate other rules. So probably a good time to stop, pause. Any questions from the audience? Any questions? Today, this works with Juniper, but ultimately, as we develop, so right now today, this specific product would apply policy to Juniper firewalls and that piece of it. However, down the road, when we define the policy engine to work with third-party products, then it would be able to take, instead of creating a Juniper policy, it would create a third-party, I'll call it, for lack of a better word, firewall filter for a switch or router based on the REST API, and be able to then push that to that device through a well-known API or netconf config protocol. So that'd be the idea. Today, this framework is for Juniper. The next piece would be to work with third-party elements that have a well-defined REST API or netconf protocol. Actually, it is at both. So it would be at the, so I think of it for two, the firewall can be a detection and enforcement point because that's where the policy is. But if you think about what I just said, if I created a policy here, security director, if I create a policy, I might need to push it two places, to a firewall and to a switch port. So in this case, I would push a security policy to a firewall, but a firewall layer 2 or layer 3 filter to a switch port. This policy engine that I showed you in the one picture would actually use the netconf protocol through our policy engine to push it to either a Juniper switch or router or a third-party switch if they've got that protocol.
That is the enforcer, but how about the detection?
So the detection would be, let's say I've got a laptop, I'm plugged into a switch port. That switch port has firewall filters that have been applied as detection points for that switch port, whether it's an access or a trunk port. And if I see an anomalous behavior on that switch port, that information gets fed to the policy engine or the enforcer and says, hey, I'm getting data coming from this switch port that is not normal behavior based on the current policy that's for that switch port. That means then the policy engine then will analyze that information and say, okay, I'm going to write a policy that, because that is misbehaving, I'm going to write a mitigation policy to block that port because that's not normal behavior. So it takes that device or whatever on that port and basically shuts the port off, if that makes sense. So I detected it incoming from a device, or if it was going the other direction coming into my network, so both directions. Because again, if I brought this laptop, I was outside yesterday and I come into network today and I plug in and something goes on and I got a bot virus or malware that's going outside, that's going to be misbehaving on that port, that's going to trigger the detection point on the switch. Yep. And if you think about it, it could be within the same VLAN or my next router hop, right? Because let's say, if you think about it from the perspective of if this device should not be calling out with data, ultimately it's got to hit my next router hop, right? And then off the network it goes. So it has to be in VLAN as well as outside VLAN. You have to be able to apply it at any point of the network to, quote, mitigate, okay? So that is the fundamental piece of SDSN, which is knowledge you've gained from outside, knowledge that you have within, but it's a zero trust model. Every port in your network is zero trust no matter where it's going, and policy allows or disallows.